Half-wave rectifier. A half-wave rectifier converts an AC signal to DC by passing either the negative or positive half-cycle of the waveform and blocking the other. Half-wave rectifiers can be easily constructed using only one diode, but are less efficient than full-wave rectifiers. Let's see some of the applications of half-wave rectifier. One of the example that we can take is hairdryer with a high and low speed switch. At low speed, a series diode allows the circuit to draw current on only half of the voltage cycle. Another example that we can take is an electronic mosquito repellent. Many electronic mosquito repellents operate on low voltage DC power even when connected to an AC power supply. A half-wave rectifier is used to convert the AC supply into a pulsating DC voltage. This DC voltage powers the internal circuits of mosquito repellent to drive the lead for the fumes. Now, what is exactly a half-wave rectifier? Let's say you have an alternating current power supply and you connect it with a light bulb. The light bulb will turn on. The results will remain the same if we reverse the leads since we are using an alternating current power supply. However, if you put a diode, the result will be the same if we're using the first leads, but when we reverse the leads, the diode will block the current and the light bulb will not turn on. Why is this happening? Let's jump right into it.
This is Muhammad Ashir bin Wahab, and I will explain about half rectifier for positive wave. So first of all, we need to build the circuit where there are AC power supply, transformer, diode, resistor, and oscilloscope. AC wave current flow in this direction, and if it flow in this direction, we call it as reverse direction. 60 Hz on this AC power supply means current changes 60 times every second. From this transformer, we will obtain AC wave on the output. This means here. And the current will only flow in this direction. And it can't flow in this direction because the diode will block it. Thus, we can use diode for half wave rectifier. So by that, we can use diode to convert from AC current to DC current. And AC current, there's two directions, while DC current, there's only one direction. And on this point, the current will be positive, and while this point, the current will be negative. So here is the sine wave for this circuit. So as we all can see, the blue line is for the input, and the red line is for the output. So the output for this circuit will be up half of the sine wave. So that's all from me. Thank you.
Assalamualaikum and greeting. My name is Muhammad Aziz. I will explain about half-wave rectifier for negative wave. First of all, we need to build a circuit. In the circuit, we should put AC power supply, transformers, diode, resistor, and oscilloscope. When AC power supply turn on, current will flow to the positive direction first. The current will flow to transformer's input. In the transformer input, we will get a full wave rectifier. For example, current from transformer's input will transfer to transformer's output, either it step up or step down. But for this circuit, we have 10 retro-1 transformers, so it will go to step down. Current from the positive direction cannot go through the diode because the diode is on the opposite direction of it. So positive wave cannot be obtained. So when the current from negative direction flow from transformer's output, it can go through the diode, so negative wave can be obtained. It proved that this node is more positive than this node. So here the result in transformer's output. As you can see, there are no positive wave in transformer's output because diode block the positive direction. But there are negative wave in transformer's output. At the end explanation, we can see that diode can change AC wave to DC wave.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Atim Shah. I will explain to you on how to do a calculation in half-wave rectifier. As you can see, there is an example shown on your screen to do calculation for half-wave rectifier. First of all, we must find the voltage for secondary circuit using the formula Vs per Vp equal to Ns over Np, which we represent as voltage and represent as number of coil. But before that, I forgot to mention the number of coil and which circuit is the primary and secondary example. Let me write down it for you. Now, let us put the value in using the the value in the formula. Vs over 120 equal 1 over 9. So Vs equal to 120 over 9. And we got our answer 13.33 volt. That is our voltage on our secondary circuit. Now we are going to find the peak voltage for our secondary circuit. We are going to how to find the voltage peak for secondary circuit is using the formula of voltage secondary RMS multiply with square root of 2. So 13.33 multiply with square root of 2 and our final answer is 85.85 volt. But that is not our final answer because there are 0.7 volt diode on the secondary circuit which the voltage must go through first. So 18.85 volt must be minus with 0.7 volt of the diode. And our final answer is 18.15 volt. That is our voltage peak for secondary circuit. Now we are going to find the volt average for the secondary circuit. How to find the volt average for secondary circuit is we using the formula of V voltage peak over pi. So 18.15 over pi equal to 5.78 volt. That is our voltage average. So you might wonder how I got the formula to find the volt average for the secondary circuit. So frequency average equal to 1 over V minus A. Integrate of BA fx dx. So 1 over pi minus 0 integrate pi 0 V peak sin x. dx equal to v peak over pi in brackets negative cos x in brackets pi o equal to minus v peak over pi in brackets negative in brackets cos pi minus cos o equal to v negative v peak over pi brackets negative 1 minus 1 equal to negative v peak over pi brackets negative 2. So we multiply them 2v peak over pi. But this equation for full wave rectifier. We want half wave rectifier. How are we gonna find that? So gonna use V average equal to V peak over pi. We will represent using the sinusoid with the sinusoid graph, which we will explain the one loops equal to half a loop is pi 1 pi. Meanwhile, a complete loop is 2 pi. So in our case, the half wave rectifier will have a distance between one loop to another, which will leave to us V average equal to V peak over pi. That is how we get the equation for V average for half wave rectifier. But there are another way to find the V average if they didn't give you the value of volt, but instead they gave you area and length. So in other words, how you to find the V average for the circuit is area over length. So area is the area of the loops, meanwhile the length is from one point to another point in the loop. That is another way to find the V average for half wave rectifier. That's all for me. Thank you.
Eyes in the sky, gazing far into the night. I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light shine through. If you believe it's true, baby, won't you let the light shine through?